Hey guys, welcome to my talk, Unlock the Future, Built-in AI in Browsers. Better start learning to speak robot, isn't it? AI is rising. Everybody know AI is everywhere. AI even in our everyday life, like virtual assistants, recommendation systems, autonomous vehicles, even food. We have Coke with generated flavor. Come on. AI these days is not just a buzzword. Everything is focusing on AI because it is shaping the future of our industry. My name is Mohamad, Senior Software Engineer in Netherlands, ING Bank. This is the QR to my page, so we can connect on LinkedIn, have a chat, keep up with each other. Why not? I love to connect to enthusiastic developers, and you are, since you are here in this conference. So, what's the plan? First of all, we will focus on local LLMs. So, and compare them to cloud LLMs because we have two types of LLMs in this case, and we are focusing on built-in ones, which is some kind of local LLM. And then we will make everything technical, focus on the API and overview how the API works. Then we have some live coding. Guys, finger crossed for me because live coding is always. So next step, yeah, what lies ahead? So what is the next step that we can take or what's going on behind the scene later? So let's start with local LLMs. So let me define LLM in a simple word. In a simple word, LLM is so simple. We have a prompt like, where is Amsterdam? It goes to LLM and then it gives us a response, Netherlands, right? Converting a prompt to a response using LLM is the one that we are going to use. In a more technical way, LLM is a large language model. It's type of artificial intelligence that uses deep learning techniques to understand, generate, and manipulate human language. So this kind of LLM, first of all, focusing on human language. So it can generate, understand, manipulate. So yeah, like the question that we asked, where is Amsterdam? It's going to tell us. So let's see differences between local LLM and cloud LLM. We use local LLMs. LLM is on our machine. So the whole neural network and the artificial intelligence, all the technologies that lies behind would be on our machine. So we are limited to our machine as well in terms of the performance. But the thing is, there are some benefits. The first thing is privacy. Why privacy? Because when we are using local LLMs, the data stays on your machine. It doesn't go anywhere else. So you shouldn't send data through the wire to cloud and expect, I don't know, Azure, GCP get back to you with some results or some other services. So the thing is, yeah, privacy, which matters a lot. It's one of the biggest advantages of local LLMs. Then low latency, because everything is on your machine, low latency, you shouldn't wait for network and stuff, internet connection. So nothing is required in this case because everything is on your machine. And then low cost, because no subscription is required for this one. So because the LLM is, just imagine there's a database. The LLM database is on your machine. So everything gonna work. Some examples I can say, Mistral is one of them, and Llama from Meta. These are local LLMs. Cloud LLMs. Yeah, of course, with cloud LLMs, you have a superpower, as I mentioned. So since the model would be on your machine in terms of the local LLMs, but the cloud LLM, yeah, the model is somewhere in the cloud, so it could be super big. So it means that they trained it with more data. They have a better superpower there. So the other one is network latency. Yeah, it is up to date with a lot of data. It can give you better answers, but it has latency because you should send the data over the wire. So bigger data, slower. Bigger data, it should compute more. And also high costs. So it has a costs because we are using third-party services like Azure or GCP, Google Cloud Services. That's it. So in this case, we reach that, yeah, let's have a local LLM on our machine. And thanks to the browsers, which install on all of the machines, and web application, that the application that we develop and lies there. So it means that, yeah, if we put an LLM inside the browser, wow. So some kind of superpower in our machine, we can perform some magic. So let's see how does the API looks like behind the scene. First of all, disclaimer, for the things that you are going to see, no machine learning is required. So don't worry that you don't have any knowledge of ML and other things. So no ML, no machine learning is required. No AI knowledge is required as well. So you're going to see how does it work. So the API is super simple. First of all, you should create a session. Since it is asynchronous, yeah, definitely we need a wait. So AI, that assistant, that create. So if you grab the AI object from window, that assistant, that create, you're going to create a session for yourself. So in this way, you can start prompting, asking questions from LLM. Next step is prompting. As you see, with the session that I created, I called .prompt and then text my question, actually, my prompt. So where's Amsterdam in this case? So do you remember that in the other diagram I showed you, yeah, the answer is Netherlands? Yeah. Based on the data that the model has been trained for, so the answer might be different and also a lot of different parameters, but generally the data matters a lot. So for me, in the test that I did, it gave me this sentence: Amsterdam is the capital city of Netherlands. Nice. So with 2 lines of code, I could ask LLM something. So just imagine how creative could you be in your applications to interact with the user in a better way, gives them better suggestions and stuff. So we will see some use cases later on. The other API that matters a lot is prompt streaming. As LLMs are using generative technology, generative AI technology. Generative AI, it literally means generating. When you call prompt, so it just waits for the LLM to generate all the content, all the response. But if you use prompt streaming, it's different. It's the same thing, but as soon as LLM predict the next token, which is the next word, just imagine in this case, so it's going to give you the output. So this is a standard stream in the browser. So you can just wait for that and expect some chunks from the stream. So as you see, the output would be something like this. The first Amsterdam, then is the capital city, is the capital city of the capital city of the Netherlands. That's how it works. When you're dealing with prompt or prompt streaming, just imagine how does it work. This is a cool API from the prompt, from the built-in AI API. Yeah, no ML expertise required, no AI expertise required, no neural network, some magics. But to be honest, prompt engineering can make it much better. So there are a lot of prompt engineering out there that you can check them out. First of all, how to write a better prompt, how to ask LLMs, or what are the tricks that you can use? What are, how LLMs can answer you better? So these are all the things that you can learn. For instance, one of them is in-shot prompting. In-shot prompting, it's like giving some examples to LLM. Please use these examples and get back to me like I asked for. So let's start from the top. I'm using, again, AI assistant that creates. Then I'm passing 2 parameters, temperature and top K. So these 2 parameters are so detailed. I recommend you to read them in the documentation that I'm going to share the link later. But generally, The temperature, for instance, in this case is something like how creative LLM could be. Most of the time, if you set it to 0, it's something like it's going to give you the same answer all the time, somehow. And then I initiate prompts, some system prompts, some kind of persona. I give a persona to the system, pretend to be a tour guide. And then I give some examples. For instance, for Netherlands, if user asks, the assistant says, let's go to Rijksmuseum. If I talk about Italy, say, let's do Colosseum. See, these are well-known museum tourist places. What if now I ask something new? Tell me something about Iran. The thing is, since LLM just learned that, yeah, my user expect this kind of sentence. Let's go to somewhere. Yeah, the answer, the response in this case would be, yeah, let's go to Grand Bazaar. Why not? So nice. That's how it works. So it's one of the techniques to improve your prompt, which is in-shot prompting. So it's time for some live coding. Finger crossed. Let's see what do we have. I have a simple form, add blog post. I'm going to put my context and tags for that blog post. So let's use the API that we just learned to just improve our application simply. So you remember what was the API, right? So it means that if I want to run the API, I should run it on the text change. So let's see the code that I have. Really straightforward. Add event listener on the inputs of my text element. Nice. So far, so good. In the prompt function, I have an asynchronous function. I am awaiting to create a session, simple. Then I'm prompting my LLM, my local LLM. So my prompt is something like this. You are an author helping people to find the right tags for their blog posts. Nice. Some kind of a persona. Consider the following text and suggest tags for it in a JSON format. Yeah. Every developer's favorite format, right? Is it? Yeah. Anyway. So I'm going to put the text inside an HTML type, XML type. It could be anything. It could be back tag, back tick, or something else. But to be honest, I prefer in this format because LLMs most of the time understand it better. So I'm awaiting for the response, getting the response, and just log it. So let's see what do we get from the text. First text is AI is awesome. Let's see the console. Come on. Oh, yeah. As you see, it took a little bit time, and it makes sense because it was computing on my machine with all the stuff. Yeah, it is somehow in JSON format. As you see, it gave me in a markdown format, which we are going to trim it. But yeah, we have an object full of tags. For the AI is awesome. It detects artificial intelligence. Nice. An AI tag. Yeah, nice. So we are going to show tags here for our application. I am so happy to be here. Let's see. Okay, yeah, in food, come on. Because I'm just typing, it's gonna run the function on each of my keypress. So that's why you can see a lot of logs here. Yeah, the last one is this one. Yeah, happiness. Yeah, it could be a good tag for my blog post, which contains this text at the moment. Or it has a lot of others as well. Sentiment, tone, emotions. Nice, but anyway, this is the last one and the most accurate one. Because right, yeah, at this time it had all the text. So let's use it. So I want to extract tags, right? So my response contains some backtick and the JSON in the front. So let's replace them. Then I'm gonna use regex, find all the backticks, and yeah, just move forward. Everything that you found, replace it with nothing. So these are the tags. Yeah, the tags string. So let me parse it with JSON.parse as well to make it a JSON and an object. And let's log tags for myself. Let's see. What do we have in the browser? So text is happy. Yeah, nice. Tags, happiness. Great. So far, so good. What else? So let's have a for loop. Our tags. Nice. I have a UL here, name tags. I'm getting it by ID. We have tag element. So let me create an LI. Oh, nice, nice. Thanks, Copilot. We have an LI, set the text content to the tag itself, append it to the tags. Let's see the result. Refresh. Happy. Yeah, live coding. You should wish me luck, but why you didn't? Anyway, let's see. What's the problem? Let me put a log here. Nice. Tag element append. Okay, li, create element li. Yeah, everything makes sense. I just want to make sure that we have some content for the tags. So yeah. Oh yeah, guys, tags. It has property tags. So yeah. So I'm gonna just put tags there. So right now we have tags. So everything makes more sense. Let me go for happy. Cool. Yeah, yeah. See, yeah. Since I was typing, so yeah, music, happiness. It's all those prompts that it was doing during my typing. So I can do two things. Let me go for tag element in HTML empty. Yeah, because yeah, each time I should clear the list. So even I can set a loading or something, which doesn't matter in this case. Yeah, happy. So, okay. Oh, yeah, it's working. It's working. Anyway, you can see happiness here. So if you want to create a tag, you can, use this suggestion link to create a tag. And also, as these are just redundant, right? So I have already loaded the Lodash here for myself. So yeah, easily let's use the bounce from Lodash, put it to 200, 300 milliseconds, something like that, to just debounce all of them. So happy. Yeah, just one, super fast because yeah, there aren't a lot of prompt to my LLM, which is my computer, so it's gonna make it slow, so on and so forth. So easy peasy. So as you see, we just, I don't know, from 55 to just 85, 20, 25, 30 lines of code, simple code. So I could prompt LLM, get some tags for my blog post and just suggest them to the user, make my user's life easier. So everything is great. Let's try it out for the last time. AI is awesome. I am presenting. Let's see what are the tags that it suggests. Conference. Yeah. Technology, artificial intelligence, conference. Yeah, very good. So it means our application is working in the way that we want. And yeah, that's it. So let's. So maybe you wonder, how did I? Oh, sorry. So I'm gonna start right now, okay? So yeah, after the demo, so we can cut it and right now the second part. So maybe you wonder, how did I set up this API in my browser? First of all, download Chrome, Canary, or Dev. It doesn't matter. For sure, latest version. So if you go to this URL, these are internal URLs of the Chrome /flags. And if you search for prompt API for Gemini Nano, yeah, just make it enable. And also another flag in the flags URL, optimization guide on device model. So you should enable that one as well. Enable bypass perf requirements. Who named it like that? Anyway, the last thing that you should do, and actually it is one of the most important one, is downloading the model itself. If you go to Chrome URL components, so you will find this name, optimization guide on device model. Just click and check for the update. So it's gonna check for sure there is no model on your machine. So it's gonna start downloading. So you just need internet connection for the first time to download it. So it means that later on, if somebody wants to use the API, the model has been downloaded and can use it. So what's the next step? What lies ahead? One of the most important thing, step after my talk, after the thing that we just learned, is you. So I want you to join built-in AI program from Google. This is the URL. This is the QR to that page. Just join the program so we can help each other understand more, look what's going on. If you face an issue, because we are talking about the future, right? Since we are talking about the future API that is coming, so for sure it's not stable. Even from time to time, I face issues as well. So keep in mind, it is very important. So to just make your hands dirty with the code to experiment it. So this is the URL and QR. So thanks for joining. And also, from time to time, people ask me, so how do you see this AI? Where does it go? Will AI replace us? To be honest, I always believe in this sentence. The best way to predict the future is to create it. So right now we have the API, we have the AI, we have the LLMs, we have the APIs. Everything is there. Come on, guys. We are living in a world full of innovations, APIs. So let's keep it up. Just try to use the latest APIs and stuff and start learning, create something. It shouldn't be production ready something, or it could be even one simple page for yourself. Yeah, why not? Let's start using these features. And in this way, you can predict the future. You can see what are the features that are coming. So in that way, yeah, you can adapt yourself to the future. So sooner or later, if something happened to our industry because of the AI, so you are ready for that, at least before that, predict that. So let's see some use cases of this API. For instance, classification, tagging, keyword extraction, helping user to compose text, summarization, generating titles, headlines for the articles, answering some question based on the unstructured data. So you know that the data in web pages or PDFs and stuff are somehow unstructured. So you can, because LLM understands it better than us. So it's not something, most of the time, it's not tangible to our eyes, but to LLM, it is. Also, translation between languages, it is one of those APIs that is coming. So a lot of features are coming, a lot of use cases for this API. So yeah, it's us that we should think about it and start innovation. So if we know that this API exists, so we can adapt ourselves to the newest changes. So yeah, AI is everywhere. Let's be part of it. Thanks for listening. If you have any questions, my email is here. Also, the QR to my page, all my social media links are there. I would be super happy to have a talk with any of you. Happy to see you guys. Hope catch up next time.